This last video is our wrap-up video. So we were learning about linear equations, section 2.3. This is everything that I said we would cover. So we started off with just talking about what we mean by linear equations when we refer to this section. First order linear equations can be represented in a general form, and we talked about the form that you need to rearrange every problem of this type into in order for it to work. And then we did this derivation that took a little while. We talked about how you pick the p of x function from that standard form, and then if you just imagined having this special e to the integral p of x dx, you could do a bunch of derivatives and rearrange things in order to turn our ODE from dy dx plus py equal to f, something that you don't know how to solve, into a simple integration problem. And we said that that's an approach that we're going to use a whole lot in this class, the idea that we have special tricks for turning differential equations into integration problems, which you're already equipped to handle. And then we talked about kind of why this is helpful and the steps that we use to actually solve this method. So again, reminding you that you have to get it into that standard form, and then the different steps you take, pointing out that even though we have a formula for this, it is not like demonstrating the steps to solve it if you use that formula. So the way to do it would actually be this way, where you kind of work through the whole differential equation and show your integration. And then we did kind of a simple example to start. We found a general solution to a differential equation, and then we thought about if it was an initial value problem in two different ways, the simple solving for C way or the definite integral way, same as we had with separable equations. And then we did that application problem where we had the change of notation and we were dealing with a physical problem of finding the concentration in this tank with fluctuating like source and exit densities of brine. And something that was interesting about this problem was that we actually talked about this idea of transient terms. So we thought about what the equilibrium of our solution was. We thought about what the solution actually did as time went on. And we connected those two ideas, demonstrating that we get the same answer for what happens to the solution because part of the solution goes away. That was a bit of vocab for you and getting us thinking about these solutions as actual functions related to equilibrium values. And then the last thing we did was we talked about what happens if our f function, the thing on the right-hand side of the differential equation, is piecewise. And sort of the answer was you started exactly the same way as usual, but integrating a piecewise function is more challenging than integrating a non-piecewise function. And so what you do is you just break it up into the different parts. There's going to be a temptation to only think about the part that matters to you. You have to integrate both parts. And after you integrate both parts, you kind of just plug them into your formula for y separately, solve for what y would do in either part. One kind of important thing that we talked about for this, was that the initial condition we solved for C in kind of our first part of the piecewise function. But in our second part of the piecewise function, if you have an integral that's non-trivial, if the second part is not 0, then you would actually have an unknown constant that you have to solve for by thinking about what happens at the break between the two pieces at x equals 1. All you have to do, we said, is just plug in x equals 1 to either definition of y, and then set those two things equal. Make sure that you're continuous across that breakpoint in order to solve for any constants that are left. So I wrote on this page what the wrap-up said. We learned to identify first-order linear equations. We talked about why we build them in this special way. We talked about the steps to solve the ODE. And then we did some examples. And one of the important takeaways is that piecewise functions are going to be tricky. And so I wrote again here that you need to please remember that you use the initial condition to solve for the first unknown constant you find. And then you use the breaks, continuity across like x equals 1 or wherever your function changes, to solve for any extra unknown constants. That'll come up in your website. So your practice problem, the thing that you should do before class to make sure that you understand the basics of these first order equations before turning to your homework, that's just going to be to find the general solution to this differential equation. dy dx equals 3 minus 3y. And again, a general solution is going to be some y equal to something plus c, or y equal to c times something. So go ahead and work on that, and I will see you in class.